Mr. Glenn, what do you want, boo? I was wondering if you can help me with this chemistry question. We went over this already. I know, but I'm still confused in some things. Okay, let's get something clear here. Uh-huh. This is my classroom now. What do you mean now? It always has been. I'm the smart one now, not you. Why do you keep saying now? Ow! Let's jump into question number 1. As you can see, all the answers given to us are alkenes. To answer this question, we must first understand the oxidation of alkenes using KMNO4. There are two types of oxidation. There is the cold one, and there is the hot one. Let's ignore the cold one because the question specifically says for the hot one. Now the hot one is a lot more complicated. The oxidation basically takes place by splitting the alkene right in the double bond. Once the alkene is split in two, we can determine the product of each oxidation reaction. Each of the end product depends on the structure of the alkene itself. You can see the end product of each alkene structures right here. Since the product of the reaction is a carboxylic acid and a ketone, we can safely say that the structure of the alkene we're looking for are this and that. The answer that matches this description is delta. These are the answers given to us from the questions. Before we answer this question, let's talk about carbonyl. Carbonyl is an organic molecule that can either be an aldehyde or a ketone. A 2,4-dinitrophenylhydrazine is a test for carbonyl. The Fehling test is a test for an aldehyde. I don't really want to get too technical with the reaction of those tests, but here are the positive and negative of both tests. With the 2,4-DNPH test giving a positive test and the Fehling test giving a negative test, we can safely say that the compound we're looking for is a ketone, and the only ketone from the answers that were given to us is A. The question gave us a 3-stage synthesis reaction from ethanol into product R. When ethanol reacts with hydrogen cyanide, it produces a nitrile. That is product P. When a nitrile is treated with aqueous H2SO4 refluxed, we get a carboxylic acid. That is product Q. Now the question tells us specifically that there are two molecules of product Q, which in turn react with each other, producing product R and two molecules of water. The question also mentions that product R has an ester bond. This indicates that esterification occurred in the reaction. But what is esterification? Esterification is a reaction between an alcohol and a carboxylic acid, which then produces an ester and water. But Glenn, I hear you ask, we don't have any alcohol. We only have 2 carboxylic acid. How can that make an ester? Think in your dumb peas. Remember, we have 2 carboxylic acid. That gives us 2OH and 2COOH. That allows the 2 carboxylic acid to react with each other, creating a ring-like formula, as you can see. With the formula we've discovered, we can finally find out what is the empirical formula for molecule R, and that answer is B. The question is again about molecule test. You have learned about the 2,4-DNPH and how it tests for carbonyl. You have learned about the Fehling test and how it tests for an aldehyde. Now we spot something different. It's an iodine test, or it can also be called a triiodomethane test. This is how the iodine test works. The iodine test basically tests for molecules that looks like this and this. The positive and negative of the test is presented there. So the question states that it got a positive test for the 2,4-DNPH. It got a positive test for the Fehling test. It also got a positive test for the iodine test. But Glenn, I hear you ask, how can it be positive test for both aldehyde and ketone? Dumb! Dumb! That's a dumb question, and you're dumb! If you look closer to one of the molecules, the iodine test, there. Let's see what happens when we add a hydrogen instead of an R group in that spot. What do we get? We get an ethanol. Ethanol is the only aldehyde that can test positive for the iodine test. We can safely say that ethanol is the answer because it tests positive for the 2,4-DNPH, it tests positive for the Fehling test, it tests positive for the iodine test. Question number 5 states that P, Q, and R are structural isomers for C4H10, all in which the colorized bromine in the dark. We can safely say that P, Q, and R are alkenes. The question also states that P and Q exhibit stereoisomers. R exhibits cis-trans. P, Q, and R are oxidized with KMnO4 to see their end products. Let's process those information. You have heard me say isomers a couple of times. But what are isomers? Isomers are the same molecular formula with different structures. There are two types of isomers, structural isomers and stereoisomers. Cis-trans is a part of the stereoisomers. We can safely assume that molecule R is either in that structure or that structure. Let's see the product of P, Q, and R when they're oxidized and see if that can give us more of an answer. Flashback from what we learned from question number 1, the oxidation of an alkene. The product for molecule R states that it only produces carboxylic acid. Therefore, we can safely say that product R exhibits this type of alkene structure. Therefore, molecule R is that. The question states that Q's product is a CO2 and a carboxylic acid. We can see from what we learned from number 1 that product Q exhibits this sort of structure for an alkene. Therefore, molecule Q is that. The question states that molecule P produces a CO2 and another molecule, molecule S. From what we can see, it's possible that the molecule S is a ketone. We can safely say that molecule P exhibits this sort of alkene structure. Therefore, product P is this. We mentioned S being a ketone. Now that's the easy part. Therefore, S is this. Wow, Mr. Glenn, you're the best human being I've ever met. You're like a god. Settle down, Boone. I am no god. I am more than one.